So in this little quick video, I'm going to go over and, oops, there, my KX3's there, a little bit of my amplifier that I built. So, previous video, I detailed a little bit about the back panel, see if this thing focuses. I'm just doing this on my cell phone. So, kind of already seen it, back panel. The case is actually comprised of two 3D printed portions and then a fan holder for the actual fan. This whole entire design is kind of based off of a hybrid between a KXPA 100 and a cheap Chinese amplifier. And you'll kind of see what I mean when you look at this. So first thing I'll do is I'll take off the 4 mounting screws. So it's pretty simple how it holds together. All right, and for reference, I should get my other amplifier. So, gotta pull this too. There we go. So, there's the first half is this, and you can all instantly see the OSH Park purple PCBs, and this whole piece then slides off. So it's a 3-deck amplifier. Come on, focus. There we go. The top portion contains the tuner units, so this uses C0G caps. There's the highest cap is actually 300 picofarad caps in parallel. Past about 300 picofarads is where you want to use silver mica, but for something like this, NPO or C0G caps are just fine. So we have the lowest capacitance here at 10 picofarads going up to 20, 40, 80, and so on and so forth. And then we, of course, also have a 62 nanohenry inductor, a 128 nanohenry, 250 approximately, half a nanohenry, or half a microhenry, 1 micro, 2 micro, 4 micro. So it's a 7 inductor, 8 cap, with one inductor, with one switch to go from high side, low side, so it means 8 bits total. On the back side of this PCB, there's actually an I/O port expander. USB comes into here to an Arduino Leonardo. Come on, focus. And let's see, I'm trying to remember what this chip. Oh, this is the one of the relay driver chips. And then you might be able to see it on the back side. There's more relay driver chips, and then there's I/O port expanders on the next level. This next level here is actually the low-pass filter. So this actually just plugs in. If I can get it to unplug here. Come on. There we go. So a few hacks and kludges here. This has an extra set of wires going to a little Chinese voltage regulator to drive the fan at like 2.5 volts. So there's an I/O port expander. I had to do a little bit of hacking and kludging to do some RS-232 level shifting to properly take into account what the KX3 was doing. So this has bandpass filters for, I think this, come on, focus, hello. Focus there, thank you. 80, 40, or yeah, 80, 40, 20, 15, and 10. Actually, no, this is probably the 80. Yeah, this is the 80 meter, and this is the 10 meter. And then all the boards are connected together via standoffs. There's a 1/10-inch header that actually does the RF signal pass-through. Later future versions of the PCB will probably be a aluminum standoff that goes through. All this whole entire design, so the KXPA 100 from Elecraft actually has almost the exact same design, where they have a PA board on the main board, they have the low-pass filters, and then they have a tuner module on the top. And the tuner module is optional, but for me, the way I designed this, it's not optional, but it's cheap enough. And then there's surface mount LEDs, and then there's an SPI port expander right here that actually does all the digital ports and whatnot. Oh, and then there's an SWR bridge here too. All the SPI ports come through this port here. So there's ground, power, ground, and everything else. So power gets passed up to, so the main power comes into here and then gets passed up to here, and then there's power that goes up and actually powers the Leonardo up here. So this board is actually hard to program just by itself. You actually have to have it plugged into the system. This whole system is based off of one of these. This is a $18 kit off eBay, and it is a pair of IRA 530s, but they don't come with a low-pass filter, and I've got one that I had built up previously. Wasn't too excited about the design, but in general it's okay. It kind of works, but I thought I could improve on it a bit, and since I already had the heat sinks for it, I said, well, why not? And so thus was born the Quickie 50 amplifier. So the main board on this one looks almost exactly the same. I don't want to go through the process of taking these standoffs off, but there's a relay TR switch, almost the same feedback resistors here, the same core, pair of IRA 530s. I just have a power connector over here instead, along with an RF input, and then the RF output is coming up through this little white Teflon coated wire up to here, because I changed the design of this bottom board, where originally I had the power coming in on the front because it was a little bit easier. So originally it come in this way, but then when I did that, the ergonomics of plugging this in with the KX3 became a real pain in the butt. So I just found it better to actually have all the cables and everything coming out one side. So I revised this board, and while I did that, I made it so that the output right here, if I ever redo the LPF board, I can just put a standoff in and bring it straight up. But for now, it's just a wire going through, and at 40 and 80 meters where I'm normally operating, or maybe 20, the wavelength and impedance mismatch of this little section is nothing to worry about. So just makes it a little bit of a pain in the butt to pull apart. So that's the overall internal workings. So it looks almost exactly like this. But yeah, that's my amplifier. Thank you.